So I was walking around, talking around to people a bit before we got started, and there are a lot of new faces in the room. I feel like there's an increase in excitement around Bitcoin right now, and that's great. So for those of you who are new to this space, I'm going to be talking about some technical details here, so you're going to get to drink from the fire hose a bit. And if you don't understand something, feel free to ask me questions, or other people in the room after the event, because there are a lot of people here that know a lot about this stuff. So tonight I'm going to be starting off talking about the new cool stuff in Bitcoin Core 0.15, which is just about to be released. And then I'm going to open up for kind of open format, arbitrary question and answer, and maybe we'll have some interesting discussion. So first thing I'm going to talk about for 0.15 is just some numbers-wise breakdown. What kind of activity is going on in Bitcoin development right now? I'm going to talk about the major themes and major improvements, things about performance, wallet features. I'm going to talk a little bit about this service bit disconnection change, which is a really minor and obscure thing, but created some press. I think there's a lot of misunderstanding about it. And then I'm going to talk about some of the future work that's not in 15 that will be in future versions that I think is interesting. So a quick refresher on how Bitcoin Core releases work. So there is this master trunk branch of Bitcoin development, and releases are branched off of it. And then new fixes that go into those releases are written to the master branch and then copied off to the release branches. This is a pretty common development process for software. What that means is that the features that are in 0.15, a lot of them are also in 0.14.1 and 0.14.2, because 0.15 started with the release of 0.14.0, not with the release of 0.14.2. So back in February this year, 0.14 branched off, and in March, 0.14.0 was released. And there have been a couple of point updates fixing bugs. And then in August, 0.15 branched off, and we've had 2 release candidates. Really, there's a third. The binary should be up sometime tonight or tomorrow morning for the third release candidate. And we're expecting the full release of 0.15 to be around the 14th or 15th. It's been delayed a little bit because of developers traveling around and not having access to their cryptographic keys. Our original scheduled date for the release was September 1st, so 2 weeks slip there is unfortunate, but not a big deal. So just some raw numbers. What kind of levels of activity are going on in Bitcoin development these days? So over the last 185 days, which is the development of 0.15, there were 627 pull requests merged on GitHub. So these are individual high-level changes. Those requests contain 1,081 non-merged commits by 95 authors, which comes out to 6 commits a day, which is pretty brisk, especially compared to some other cryptocurrency projects, but not overwhelming. One of the interesting things about 0.15 is that 20% of the commits are test-related, so they were adding or updating tests. And a lot of those actually came from John Newberry, who's a relatively new contributor who works at Chaincode. His first commit was back in November 2016, and he was responsible for half of all the test-related commits, and also the top committer in this project. And then it falls down from there. A number of other people with lots of contributions, and then a broad swath of everyone else that contributed. So the total number of lines changed in the code is rather large. You see 52,000 lines inserted, but a lot of that net increase in line count was actually the introduction of new tests that we didn't have in the past. So that's pretty good. We have a little bit of a backlog in things that are under-tested for our standards. Yeah, there's some humor there because Bitcoin Core is relatively well tested compared to most software. And so all of this activity results in about 3,000 lines changed per week to review. So for someone like me that does a lot of their contribution in the form of review, there's a lot of activity to keep up with. So in 0.15, we had a couple of big areas of focus. As always, but especially in 15, we had a big push on performance. So one of the reasons for this is that the Bitcoin blockchain is growing, and just keeping up with that growth requires the software to get faster. But also, with SegWit coming online, we knew that the blockchain was going to begin growing at an even faster rate. And so there was a desire to try to squeeze out all the performance we can to make up for that. In 0.15, there's a lot of places where little bits of polish and various corner cases to make them more reliable. And there are some areas that we didn't work on in 0.15. So we haven't been working on, for example, new consensus rules. We're sort of we've been waiting to see how SegWit shook out. So there hasn't been a lot of focus in the wider Bitcoin tech community on new consensus rules. And then there's a bunch of wallet features that we've realized are so much easier to implement with SegWit that we've held off working on those for a little while. So that's when I get to the future section, I'm going to talk about some of those things that have now kind of been held back waiting for SegWit and now starting to move forward at a pretty good speed. So the first of these really important performance improvements is that we have completely reworked the chain state database in Bitcoin Core. So the chain state database is what stores the information that is required to validate new blocks as they come in. This is also called the UTXO set. And the current structure that we've been using has been around since 0.80. And when it was introduced, this structure, which basically has a separate database of just the information you need to validate new blocks, was something like 40x performance improvement. So it was an enormous performance improvement to switch to what we had. And so this new update is improving that further. So the previous structure, we often talk about it logically as a per output database. So this is a UTXO database. So people think of it logically as individually tracking every output from every transaction as a separate coin in the system. But that's not actually how it was implemented on the back end. The back end system previously batched up all of the outputs for a single transaction into a single record in the database and stored those together. And back at the time of 0.80, that was a much better way of doing it. It was much faster, in fact, at that time. But the usage patterns and the load on the Bitcoin network have changed. So this batching together that it used to do saved space because it shared some of the information, like the height of a transaction, whether or not it's a Coinbase transaction, the transaction ID, are all shared among all of the outputs. But the problem of this, or one of several problems, is that when you spend the outputs from a transaction one at a time, it would have to read in all of the outputs, modify it, write it back. And so this creates a quasi-quadratic I/O blow-up, where a lot more work is required to modify transactions with many outputs. It also made the software a lot more complicated because if a pure UTXO database would only have to create outputs and delete them when they're spent. But this merging form that we've had in the past required that there be support for modifications. That you'd be able to read a transaction and spend some of the outputs, save the rest back. And this whole process also resulted in considerable memory overhead. So what we've changed to is a new structure that stores one record per TX out. It results in a 40% sync speed up. It uses 10% less memory for the same number of cache entries, which means that you can have larger caches with the same amount of memory on your system, or it means that you can run Bitcoin Core on a machine with less memory than you could otherwise. It also results in fewer cache flushing, and I'll talk more about that in a minute. So that helps. This 40% number is a number given on a host with very fast disk, fast SSD. But if you're going to run the Bitcoin node on something with slow media, spinning disk or USB or something like that, I would expect to see faster results even than 40%, though I haven't benchmarked it. It makes the implementation a lot simpler. But there's always a downside, and the downside is that it makes the database larger on disk. So there's a 15% increase in the chain state directory. So it's 2.8 gigabytes, not a really big deal. So here's a visualization of the change. In the old format, you'd have this add, modify, modify operation. So you have 3 outputs to begin with. One gets spent, another gets spent, and then you delete the rest. And the new is maybe what people thought it was actually doing all along. This same structure has been copied into other alternative implementations. So BTCD, BCAT, the Bcoin, Damon. You tell what words I'm using a lot these days. These other implementations copied the same structure in the Bitcoin Core software before, so they all also work like the top graph. So, so this is a database format change, so there's a migration process. When you start 0.15 on an older host, it will migrate to the new format. On a fast system, this takes a couple minutes, 2 minutes, 3 minutes on a fast system. If you try this on a Raspberry Pi or something, you might want to wait a couple of hours. It's not fast on something with slow I/O. And you can't go back. So once you've run 0.15 on a node, In order to go back to an older version, you have to do a chain state reindex, and that'll take you hours. There is a little corner case where if you ran Bitcoin Core Master in a couple-week period from when we introduced this until we improved it a bit, your chain state directory may have become 5.8 gigabytes in size, so double size. And that's because LevelDB, the underlying backend database, wasn't particularly aggressive about removing the old records once they were deleted. So there is a hidden force compact DB option that you can run. It's a one-time operation that will shrink the database back to its size. So if you happen to notice on a node of yours that you have a 5.8 gigabyte chain state, run that command. The graph here at the bottom is showing the improvements from this visually, and it's a little strange to read. So the x-axis is progress in terms of what percentage of the blockchain was synced. And then on the first graph, the y-axis is showing how much time had passed. And so you can see that this purple line at the top is the older code without this improvement, that it was taking a lot more time. But if you look early on in the history, the difference isn't as large. The other lower graph here is showing the amount of data stored in the cache at a point in time. And so you see the data in the cache increases, and then it flushes the cache to disk, and it goes to nothing. Then it increases, and it flushes the cache to disk, and goes to nothing. Now, if you look at the purple line, which is the older code, it is eventually flushing very, very, very often as it gets further along in the synchronization. And then if you can see kind of overlaid here, the screen line is flushing very frequently, so it doesn't have to do as much I/O. So since this change is a change really at the heart of the consensus algorithm in Bitcoin, we had some very difficult challenges relating to testing it. Because we wouldn't want to deploy a change that would cause it to corrupt or lose records, because that would cause a network split. So major consensus critical part of the system. This redo actually had a couple of months history before it was made public, where Peter was working on it in private, tried a couple of different designs. Some of this work is driven out of the next feature that I'm going to talk about in a minute. But once it was made public, it had 2 months of public review. There were 245 comments, people going through the software line by line, asking questions, getting comments improved, and things like that. This is an area of the software where we already had pretty good pre-existing automated tests for it, but we also added some new automated tests at that time. And we also used a technique called mutation testing, where basically we took the updated copy of Bitcoin and its new tests, and went line by line through the software, and every point where we could see a place where a bug could have occurred, like every if branch that could be inverted, every zero that could be a 1, every add that could be a subtract, we made each bug in turn and ran the tests, and verified that every change that broke the software made the test fail. So this process didn't turn up any bugs in the new database, hooray, but it did turn up pre-existing non-exploitable crash bug and several shortcomings in the test. There were parts of the test that thought they were testing something, but it turned out they were testing nothing. And that's a thing that happens because often people don't really test the tests. So you can think of this mutation testing thing in your mind as normally the test is the test of the software. Well, what's the test of the test? Well, the software is the test of the test. You just have to go break the software to see the results. So that's the new chain state database. A tightly related feature we also did shortly after it is a feature called non-atomic flushing. So this database cache in the Bitcoin software is really more of a buffer than a cache. The thing it does that improves performance isn't that it saves you from having to read things off disk. Reading things off disk is relatively fast. But what it does is it prevents things from being written to disk. So for example, someone makes a transaction, and then 2 blocks later, they spend the output of that transaction. With a buffer, you can avoid ever taking that data and writing it out to the database. And so that's where almost all of the performance improvement from the caching infrastructure in Bitcoin really comes from, is this buffer operation. So that's great. And it works pretty well. But one of the problems with it is that in order to make the system crash robust, the state on the disk always has to be consistent with a particular block. So that if you were to yank the power out of your machine and your cache is gone now because it was just in memory, you want that node to come back up and have a database that's consistent with a particular block so that it can continue validation from that block. It doesn't have to be the latest block, it just has to be a particular block. So the way this was built in Bitcoin Core is that whenever the cache would fill up, we'd force flush all of the dirty entries to disk all at once, and then we could be sure that it was consistent at that point in time. In order to do that, we'd use a database transaction, and the database transaction required basically creating another whole copy of the data that was going to be flushed. So this extra operation meant that basically we lost half of the memory that we could tolerate in our cache with this really short 100 millisecond long memory peak. And so we have to basically, in older versions like in 0.14, if you configure a database cache of a gigabyte, then we really use 500 megabytes for caching, and then another 500 megabytes is just left unused to handle this little peak that occurs during flushing. We also were doing some work with smarter cache management strategies where we would incrementally flush things, but they interacted poorly with this whole flush at once thing. But we realized that the blockchain itself is actually a write-ahead log. It's the exact thing you need for a database to not have to worry about what order your writes got written to disk. And so with this in mind, our UTXO database doesn't actually need to be consistent. And what we can do instead is that we store in the database the earliest point in which writes could have been occurred, so like the earliest block height for which there were writes in flight, and the latest. And then on startup, we simply go through the blockchain on disk and reapply all of the changes. Now this was much harder when the database could have entries that were modified. But after changing to the per TXO model, every entry is either inserted or deleted. And inserting a record twice just does nothing. And deleting a record twice does nothing. And so the software to do this is quite simple. It starts up, sees where it could have had writes in flight, and then applies them all out. So this really simplifies a lot of things. It also gives us a lot more flexibility on how we manage that database in the future. So it would be much easier to switch it to a custom data structure or do other fancy things with it. It also allows us to do fancier cache management and lower latency flushing in the future. So we'll be able to do things like incrementally flush a little bit every block to avoid these latency spikes from doing a full flush at one time. Just something we've experimented with and just haven't proposed yet, but it's now easy to do with this change. It also means that we've benchmarked all the trendy other database things that you might use in the place of LevelDB in the system. And so far, we've not found any that perform significantly better. But if in the future we found something that did perform significantly better, we wouldn't have to worry about it supporting atomic transactions anymore. So also in 0.15, we did a bit of platform acceleration work. And this is stuff that we've known we could do for a long time, but it just didn't rise to the top of the performance priority list. So we now use SSC4 assembly for the SHA-256. And that results in a 5% speed up in initial block download and a similar speed up for connecting a new block at the tip, maybe more like 10% there. In 0.15, it's not enabled in the builds by default because we introduced this just a couple of days before the feature freeze and then spent 3 days trying to figure out why it was crashing on Mac OS X. It turns out the OS X linker was optimizing out the entire chunk of assembly code because of an error we made in the capitalization of the label in it. So, but this took like 3 days to fix, and we didn't really feel like merging it in and then having the 0.15 release potentially get delayed when we find out it doesn't work on OpenBSD or something obscure or older OS X. But it'll be enabled in the next releases. We've also implemented support for the SHA native instruction support. And this is a new instruction set to do SHA with hardware acceleration that Intel announced and then so far has really not put in any of their products. It's supported in like one Atom CPU and none of the interesting Intel CPUs. But the new AMD Ryzen stuff contains that instruction, and the use of it gives another 10% speed up in initial block download for those AMD systems. We also made the backend database, which uses CRC32 to detect errors in the database files. We made that use the SSC42 instruction for CRC. So another one of the big performance improvements in 0.15 is this script validation caching. So Bitcoin has had, since 0.7, a cache that basically memorizes every public key message signature tuple and will allow you to validate those much faster if they're in the cache. This change was actually the last change to the Bitcoin software written by Satoshi. He had written a patch and sent it to Gavin, and just sat languishing in Gavin's mailbox for a year. And there's some DOS attacks that basically can be solved by having a cache. The DOS attack is a pattern like this, where I basically make a transaction, it's got 10,000 valid signatures in it, and then the 10,001st signature in the transaction is invalid. And you will spend all of this time validating each of these 10,000 signatures to get down to the last invalid one. And then you'll go, it's invalid, and you'll disconnect me. And then I'll just connect you again, send you the same transaction, but with one different invalid signature at the bottom, and you'll do it again. So the signature cache is really introduced to fix that, but it also makes validation at the tip much faster. But even though that's in place, all it's caching is the elliptic curve operations. It is not caching the validation of the scripts in total. And this is a big deal, largely because of signature hashing. So for transactions to be signed, you have to hash the transaction to determine what's being signed. And for large non-segment transactions in particular, that can take a long time. So one question that has arisen probably since 2012 is, well, why don't you just use the fact that a transaction is in the mempool as a proxy for it being valid? If it's in your mempool, then it's already valid. You've already validated it. Go ahead and just accept it in a block. But the problem with that is that the rules for a transaction going into the mempool are not the same as the ones for them going to the block. Now, they're supposed to be a subset, but it's easy for software errors to turn it into a superset. And there have been bugs in the mempool handling in the past which have resulted in invalid transactions ending up in the mempool. Because of how the rest of the software is structured, that's completely harmless, except maybe wasting a little bit of memory. But if you were using the mempool for validation, then having an invalid transaction in the mempool would be immediately a consensus splitting bug. So basically, using the mempool would massively increase the size of the code base, which is consensus critical. And so no one working on the project is really interested in using the mempool for doing that. So what we've introduced in 0.15 is a separate cache for script validation caching. And it basically maintains a cache where the keys are a hash of the transaction ID and the validation flag, so which rules are applicable for that transaction. It caches that, and because all of the validity rules in a transaction, other than its sequence numbers and block time, are pure functions of the hash of the transaction, then that's all it needs to cache. And for SegWit, that's witness TXID, not just plain TXID. So the presence of this cache creates a roughly 50% speed up of accepting blocks at the tip. So when a new block comes into a node that's been running for a while. There's a ton of other speed ups in 0.15, but a couple I wanted to highlight is the disconnect tip, which is the operation central to reorganization. So to unplug a block from the chain and undo it. That was made much faster, something on the order of perhaps tens of times faster if you're doing a reorg of many blocks. Mostly by deferring the mempool processing. So previously, you would disconnect the block, take all the transactions out of it, put them in your mempool, disconnect the block, take all the transaction out of it, put them in your mempool. And we changed it so that it does all of this in a batch. So you disconnect the block, throw its transactions in a buffer, leave the mempool alone until you finish the reorg. We added some caching for compact block messages. So when relaying a compact block message to different peers, we cache the constructed message rather than reconstructing it for each peer. The key generation in the wallet was made on the order of 20 times faster by not flushing the database between every key that it inserted. And there were some minor libsecp crypto speedups in the order of 1%. 1% is worth mentioning there because speedups in the underlying crypto are very hard won. Well, 1% speedup is like weeks of work. So end result, here's an IBD chart for the top bar is 0.14.2, and the bottom chart is the 0.15 RC3, I guess. And this is showing number of seconds for an initial sync across the network. Now in this configuration, I've set the DB cache size to effectively infinite, set to 16 gigs or something. So the DB cache never fills on both of these hosts that I'm testing with. The reason I tested with the DB cache size of infinite is because two reasons. One is, if you have decent hardware, that's the configuration you want to run while syncing. Two is because with the normal size DB cache, which is sized to fit on a host with a gigabyte of RAM, it takes so long that I didn't have patience to finish the benchmarks before tonight. They'll finish sometime around midnight tonight. Now, the two segments in the bars are showing how long it took to sync to a period of about 2 weeks ago. That's the outer point. And the inner part is showing how long it takes to sync to the point where basically 0.14.0 was released. And so what you can see is in the lower bar where it's considerably faster. It's almost a 50% speed up there. It's actually taking about the same time as 0.14 as 0.14 took to sync when it released. So all of these speed ups basically got us back to where we were at the beginning of the year in terms of aggregate total size, just due to the blockchain growth. And these numbers, they're in seconds, so they're probably not real clear. The shorter bar runs out to 3 hours, is what that is. And that's on a machine with 64 gigs of RAM and 24 cores, syncing off a gigabit Ethernet. So, out of the realm of performance for a while here. 0.15 has a long requested feature that people have been asking about since probably 2011, I guess. Multi-wallet support. So right now it is only a CLI and RPC only feature. So this basically allows the Bitcoin Core wallet to have multiple wallets loaded at once that are completely separate. And it's not supported in the GUI at the moment, but it will be in the next release. Some features we do CLI first because they're easier to test, and because most of the developers are using the CLI. You just configure with a wallet conf argument which wallets you want. Each wallet's completely separate. You can tell the CLI which wallet you want to talk to, or if you're using the RPC, you just change the URL to have wallet / the name of the wallet in it. This is very useful if you have a prune node and you want to keep many wallets in sync and not have to rescan them because you can't rescan them on a prune node. And at the moment, though, this should be considered a little bit experimental. The main delay in finally getting this in 0.15 was debate over the interface. And we weren't really sure exactly what interface we should have been providing on it. And so we've explicitly stated in the release notes that the interface is unstable and we may break it in the next version. We didn't want to debate over the interface, delaying releasing the feature. And this feature has been a long time coming. We've been working on this since, I think, 0.12, doing all of the back-end restructuring. So the work in 0.15 was really just doing the UI component of it. 0.15 features a greatly improved fee estimator. It starts with the original model we had in 14, but it now tracks estimates on multiple time horizons, so it can be more responsive to fast changes. And it supports 2 estimation modes now, a conservative and an economical mode. The economical mode responds much faster. So the conservative basically says, what's the fee that basically guarantees my transaction will get confirmed based on history? And the economical is, yeah, whatever's most likely. We use the economical by default for transactions which are BIP 125 replaceable. The idea is if you underpay on one of those, you can fix it. If your transaction's not flagged as replaceable, those are much harder to fix, and so we default to using the conservative estimator. We also made the estimation machinery output a lot more data, which will help improve it in the future, but it's also being used by external estimators where other people have built a fee estimation framework that takes the Bitcoin Core estimates as an input. And this new fee estimator can also produce estimates for much longer ranges of time. It can estimate for up to 1,008 blocks back, so basically a week back in time. You can say, I don't care if this confirms anytime in the next couple of days, and it can produce useful estimates for that. It fixes some corner cases where estimates were just nuts before. The fundamental behavior isn't changed, so the fee estimator in Bitcoin has this very difficult challenge that it needs to safely operate unsupervised. Meaning that someone could attack your node, and the estimator should not result in you paying high fees because someone is attacking you. And we need to also assume that the user doesn't know what high fees are. It isn't going to necessarily ignore it if it's telling them they have to pay 100 Bitcoin per transaction. So this takes away from us some of the obvious things that we might do to make the fee estimator better. For example, the current fee estimator doesn't look at the current queue of transactions in the mempool that are ready to go into a block. It doesn't immediately basically bid against the mempool. And the reason it doesn't do that is because someone could send some transactions that they know the miners are censoring, and they could pay very high fees on them and cause you to try to outbid these transactions that will never confirm. So there are many ways that we can improve this in the future that people are working on, including using the mempool information in that way, but only to lower the fees that you pay. But that isn't done yet. So onwards and upwards. Separately from fee estimation, there are a number of fixes in the wallet related to fee handling. One of the big ones that I think a lot of people care about is that in the GUI there is support for turning on replaceability on transactions, and for replaceable transactions, bumping the fees. So you can make a transaction, and then if you didn't pay enough in fee and you regret it, you can hit a button to increase the fee on it. This was, in the prior release, an RPC-only feature. It's now available in the GUI. And with Segwit coming into play in upcoming versions, this feature will get much more powerful. There are really cool bump fee things that we can't do without Segwit. There were some corner cases where the automatic coin selection could result in fee overpayment. So basically, the Bitcoin wallet, whenever you make a transaction, has to solve a pretty complicated problem where it has to figure out which of your coins it wants to spend, and then how much fees it has to pay. It doesn't know how much fees it has to pay until it knows which coins it wants to spend, and it doesn't know which coins it wants to spend unless it knows the total amount of the transaction. So there's an iterative algorithm that tries to solve this problem. And there could be, in some wallets that were tainted with lots of tiny inputs, cases where the wallet would, in the first pass of the iteration, it would select a whole bunch of coins. I'm going to spend all these little teeny coins. And then it goes, oh, don't have enough fees for all of these little teeny coins. I need to select some more value. And so it'll go to select some more value, but the result's not monotone. It goes through and says, okay, now I'm going to spend this 150 Bitcoin input. And my fees are still high because that's where I ended up in the last iteration. Okay, I'm done. And it would potentially overpay fees in that case. Now, if your transaction had a change output, it would pay those extra fees to change. But in the case where there wasn't a change output, it would overpay. So 0.15 fixes that case. 0.15 also makes the wallet smarter about not producing change outputs when they wouldn't really be useful. So it doesn't make sense to make a 1 Satoshi change, ever, because the cost of spending that change is going to be greater than the cost of creating it. And the wallet has for a long time avoided creating low-value ones. It now has a better rational framework for doing that. And there is a configuration option called discard fee, where you can make it a little more or less aggressive. But basically, it looks at the long-term fee estimations to figure out what kind of output value is going to be completely worthless in the future, and it avoids creating smaller ones. So in 0.13, Bitcoin Core introduced HD wallet support. So this is being able to create a wallet once and then have it deterministically generate all its future keys, so you have less need to back it up. And if you fail to back it up, you will hopefully not lose your funds. So the rescan support in prior versions was effectively broken. You could take a backed up HD wallet, load it onto a new node, and it wouldn't notice when all of the keys that it pre-generated had been spent and fill up the key pool further. And so this made recovery from HD wallets for people who use lots of transactions not reliable. So that's fixed in 0.15. It now does a correct rescan and auto top-up. We also increased the size of the default key pool to 1,000 keys, so it looks ahead. And whenever it sees the spend of a key in its wallet, it will advance 1,000 keys past that. This isn't quite completely finished right now in 0.15 because we still don't completely handle the case where the wallet's encrypted. So if the wallet's encrypted, you need to unlock the wallet and then manually trigger a rescan if you're restoring from a backup. It doesn't do that yet. In future versions, we'll make it prompt you to unlock the wallet or other things to do that. And then finally, this is an oft-requested feature. There's now an abort rescan RPC because the rescan operation in Bitcoin takes hours on even a relatively fast machine. And some people would occasionally accidentally trigger a rescan and their node is useless for a while. So there's an abort command to stop it. More in the back-end minutiae of the system. We've been working on improving the random number generator. This is part of a long-term effort to completely eliminate any use of OpenSSL in the Bitcoin software. So right now, all that remains of OpenSSL use in the software is the random number generator, and the Bitcoin Qt has payment protocol support, which uses HTTPS, which uses Qt's HTTP interface, which uses OpenSSL. So most of the random number use in the software package has been replaced with using Cha-Cha stream ciphers, including all the cases where we weren't using a cryptographic random number generator. So there was like Unix RAND style random number generator that was used for things that needed to be random but not secure. But those now all use a cryptographic RNG because it was hardly any slower to do so. And one of the things that we're concerned about in this design is that there have been, in recent years, issues with operating system random number generators. Both FreeBSD and NetBSD have shipped versions where the kernel RNG gave numbers that were not random. And also, on systems where there's running inside a VM, there are issues with you snapshot a VM and then restore it, and then the system regenerates the same random numbers it generated before, which can be problematic.
There was a reason for a very famous bug in 2013 because Bitcoin J.
Oh, that's right.
Android.
Yeah.
Stolen.
So we prefer a really conservative design. So right now what we're doing in 0.15 is that any of the long-term keys are generated by basically reading OpenSSL, the OS random number generator, hardware random number generator like Intel or ERAND if it's available, and then having a state that we carry through. And future versions will remove the OpenSSL portion and replace it with a separate initializer that we wrote.
What are you using for the entropy in that?
So the entropy in that is whatever OpenSSL does, devu random, RDRAND, and then state that is run, that is carried through repeated runs of this algorithm. So I want to talk a little bit about this disconnecting service bit feature. It's sort of minutiae that I normally wouldn't mention, but it got some press, so I think it's interesting to talk about because I think there's a lot of misunderstanding. So a little bit of background. Bitcoin's partition resistance is really driven by many different heuristics to try to make sure that a node is not isolated from the network. And if a node is isolated from the network because of the blockchain proof of work, you're relatively safe, but you're still denied service. So the way that Bitcoin does this is that we're very greedy about keeping connections that we've previously found to be useful, ones that relate as transactions, ones that relate as blocks, and ones that have been up for a long time. And the idea is that if an attacker starts up and starts trying to saturate all of the connections on the network, he'll have a hard time doing it because his connections came later and everyone else is up and preferring good working connections. The downside of this is that the network really can't handle sudden topology change. You can't go from everyone's connected to everyone happily and then we're all going to drop all of our connections and connect to different people because we blow away all of that management state. And you can end up in a situation where nodes are stuck, unable to connect to any working nodes for long periods of time because they lost all of their connections. And so when we created SegWit, which itself required a network topology change, the way we handled it was front-loading the change. So when you installed 0.13.1, your node made its new connections differently than prior nodes did. It preferred to connect to other SegWit-capable peers. And our rationale for doing that was that if something went wrong, if there weren't enough SegWit-capable peers, if this caused you to take a long time to get connected, that's fine, because you just installed an upgrade, and you were perhaps expecting things to not go perfectly. This also means that it doesn't happen to the whole network all at once. People apply that upgrade over the course of months. And so you didn't go from being connected one way, 1 second, to being connected another way, another second. It was a gradual change, and it avoided thundering herds of nodes trying to connect to the few SegWit-capable peers. So that's what we did for SegWit, and it worked really well. So recently there's a spin-off of Bitcoin, the Bitcoin Cash, Bcash altcoin, which for complex political insanity reasons used the Bitcoin peer-to-peer port and the Bitcoin peer-to-peer magic and was basically indistinguishable on the network from a Bitcoin node. And so what that meant is that the Bcash nodes would end up connected to Bitcoin nodes, and Bitcoin nodes ended up connected to Bcash nodes, sort of half talking to each other and wasting each other's connection slots.
Don't cross the streets.
So this This really didn't cause much damage for Bitcoin because there wasn't that many Bcash nodes at the time. But it did cause significant disruption to Bcash. And in fact, still does today. If you try to bring up a Bcash node, it'll sync up to like the point where they diverge and then often sit for 6 to 12 hours before it manages to get connected to a Bcash node and learn about its own blocks. And in the Bcash case, it was pretty likely to get disconnected because the Bcash transactions are consensus invalid under the Bitcoin rules, and so they would trigger banning, just not super fast. So there's a proposed new spin-off in a couple of months called SegWit2x, and the SegWit2x has actually the same problems but much worse. It's even harder for it to get automatically banned because it doesn't have strong replay protection. And so it'll take longer for nodes to realize that they're isolated by these things. And so there's a risk here that their new consensus rules could activate, and you could have a node that was connected to only SegWit2x peers. Now you're not going to accept their blockchain, but they're not going to accept anything from you, and you're not going to accept anything from them, and you could be isolated for potentially hours. And if you're a miner, you could end up forking the network or creating a big amount of mess. So 0.15 will disconnect any peer which is setting service bits 6 or 8, which is the S2X and Bcash both set these service bits. And it will continue to do this until August 1st, 2018. So if something connects that's running one of these pieces of software, it just immediately disconnects them. And so that reduces these otherwise honest users inadvertently DOS attacking each other. The developer of SegWit2x showed up and complained about premature partitioning, pointing out that it only really needs to do this at the moment their new rules activate. But as I just explained, the network really can't handle a sudden topology change all at once. And we really think that his concern about partitioning is basically unjustified because SegWit2x nodes will still happily connect to each other and to older versions. We know from prior upgrades, people are still happily running 0.12, 0.10 nodes out on the network. It would take years for S2X nodes to find nothing for them to connect to. But their consensus rules will change in 2 months after the 0.15 release. So the only risk that they get partitioned is that the entire Bitcoin network upgrades to 0.15 in 2 months, which is not going to happen. And if it does happen, people will set up nodes for compatibility. But since there was some noise created about it, I wanted to talk about it. So now, let me have a drink. Just water. I want to talk a bit about future work that's in flight. So all the stuff I just talked about is in 0.15, it's great stuff. But there's lots of really cool things going on. And often in the Bitcoin space, people are looking for the Bitcoin developers to say, well, what's the roadmap? What's the things that are going to be out there? But really, since the Bitcoin project is an open collaboration, it's very difficult to do anything that's like a roadmap. So I have this great quote here I'd like to read from Andrew Morton, who's one of the big Linux kernel developers, where he says, instead of a roadmap, there are technical guidelines. Instead of a central resource allocation, there are persons and companies who all have a stake in the further development of the Linux kernel, quite independently from one another. People like Linus Torvalds and I don't plan the kernel evolution. We don't sit and think up the roadmap for the next 2 years and then assign resources to the various new features. That's because we don't have any resources. The resources are all owned by various companies, various corporations who use and contribute to Linux, as well as by the various independent contributors out there. It's those people who own the resources who decide. And the same kind of thing applies also to Bitcoin. So what's going to happen in Bitcoin? Well, the real answer to that is, what are you going to make happen in Bitcoin, right? Because every person involved in the community has a stake in making it better and contributing it to things. So no one can really tell you for sure what's going to occur in the future, but I can certainly tell you some of the things that I'm working on and that I know other people are working on. So obvious one is SegWit's fully supported in the wallet. So in prior versions of Bitcoin, we have SegWit support, but it's really intended for testing. It's not exposed in the GUI. All the tests use it, works fine, but it's not a user-friendly feature. And there's a good reason that we didn't go and put it in the GUI in advance, and that's that there is a risk that people could use SegWit before its rules were enforced and would get their funds stolen. Also, just in terms of allocating our own resources, we thought it was more important to spend our efforts making the system more reliable and faster when we didn't know when SegWit would activate before completing the rest. In any case, we're planning on doing a short release right after 0.15.0 with full support for SegWit including doing things like sending to BIP 173, it's fetch 32 addresses. That's the new address format that Peter presented on here a few months back. The new address format may also indirectly help some problems created by these spin-offs. So the Bcash spin-off, for example, uses the same addresses as Bitcoin, and people have already lost considerable amounts of money by sending things to the wrong addresses. And so introducing the new address type in the Bitcoin will end up indirectly helping, at least until there's yet another spin-off that copies that address format. Unfortunately, there is really nothing we can do to prevent people from copying things like that in a reasonable way. There's lots of further wallet improvements that people are working on. So I mentioned previously this fee bumping capability. So there's an idea for fee bumping, which is that the wallet should keep track of all the things you're currently trying to pay. Whenever you make a new payment, it should recompute transactions for the things you're trying to pay, update them to pay all those things, and potentially increase the fees at the time. It could also concurrently create time-locked alternative versions of transactions that pay higher fees. So if your transaction isn't getting in, it can pre-sign them and have them all ready to go. So we went to go design this out a few months back, and then realized that there were cases caused by transaction malleability that were very hard or impossible to solve in this, where the software couldn't work reasonably. But now with SegWit active on the network, we should be able to support this kind of advanced fee bumping as an option in the wallet. And that should be pretty cool. There's support being worked on right now for hardware wallets and easy offline signing. You can do offline signing with Bitcoin Core today, but it's the sort of thing that even I don't love. It's complicated. Andrew Chow has a BIP proposal that was recently posted to the mailing list for partially signed Bitcoin transactions. It's a mini message format that can carry all the data that an offline wallet needs to sign, and also for hardware wallets. And the deployment of this in Bitcoin Core is much easier for us to do safely and efficiently with SegWit in place. Another thing that people are working on is branch and bound coin selections to produce changeless outputs much less of the time. So this is Mark Earnhardt's design that Andrew Chow has been working on implementing. There's a pull request. It barely missed going into 0.15, but the end result of this will be transactions being less expensive for the users and also making the Bitcoin network more efficient because it's creating change outputs less often. Obviously, I mentioned multi-wallet before. The GUI is going to get support for it. There's several PRs in flight to do full block light mode, which basically run a Bitcoin node, download the full block so you have full privacy, but don't do validation for the past history so you have instant start. There's work to implement hash time lock transactions that can be used for some interesting smart contracting things. Check sequence verify transactions, which can be used for various security measures like cosigners that expire after a certain amount of time. And there's some interesting work going on for separating the Bitcoin Core GUI from the backend process. And there are patches that do this. I don't know if those patches will be ones that end up getting merged, but that work is making progress right now. So there's some interesting things going on with networking consensus. One is there's a proposal for rolling UTXO set hashes. So this is designed to basically compute a hash of the UTXO set that is very efficient to incrementally update every block. So you don't have to go through the entire UTXO set to compute a new hash. You can incrementally update it. There are many things that this can be used for, including making it easier to validate that a node is not corrupted. But I'm particularly interested in this one for the potential of opening up new ways to sync a node. To basically say, I don't want to validate the history before a year ago. Let me sync up to a state, up to that point, and then continue on further. If you do that, that's a security trade-off, but we think we have ways of making it a pretty realistic and usable one. So work's been ongoing for that. We have some interesting design questions open. We have basically two competing approaches to do it, and they have different performance trade-offs. So one is much faster in some cases, the other is much faster in other cases. So it's interesting discussion that's ongoing. We've been doing work on signature aggregation. So you can Google for my Bitcoin talk post on the subject. The idea basically is that if you have a transaction that has many inputs, maybe multiple participants, maybe multi-sig, it's possible through some elliptic curve math to have just a single signature covering all of those things, even if they're keys that are held by unrelated separate parties. So this can be a pretty significant bandwidth improvement for the system to use this. So Peter, Andrew Polstra, and myself sent a paper to Financial Crypto 17 about what we proposed implementing here. There were some tricky math problems that had to be solved. And one of the reviewers of our paper found an earlier paper that we completely missed that implemented something that was almost identical to what we had done and had even better security proofs than we had. So we've switched to that approach. We have implementation of the back end, and we're basically playing around now with performance optimizations because they have some implications for exactly what we make the interface look like to Bitcoin. And one of the cool things that we also get out of this at the same time is what's called batch validation. So you can take multiple independent transactions and validate their signatures in a batch more efficiently than you could validate them one at a time. So the byte savings from using aggregation, we ran through simulation of the prior Bitcoin history and said, if the prior Bitcoin history had used signature aggregation, how much smaller would the blockchain be? And the amount of savings changes over time because the aggregation gains depend on how much multisig you're doing and also how many inputs transactions have. So you can see early on in Bitcoin, it would have saved hardly nothing. And then later on, the savings basically stabilizes out at around 28%. It would go up if more multisig were in use, or if more coin joins were in use, because this aggregation process incentivizes people to coin join by making the fees lower for the aggregate. When this is combined with SegWit, the capacity increase from doing this, if everyone's using it, is about 20%. So it's a little less than the byte savings because of the SegWit weight calculations. Now, what this scheme does is that it reduces the size of the signature to just one signature per transaction, but the amount of computation that needs to be done to verify it is still proportional to the number of public keys that are going into it. But we're able to use this batching operation to combine them together and make them much faster. And so this chart is showing the different algorithms we've been experimenting with for doing this combined validation. And basically, they get faster in terms of speed up the more keys are involved. So at the 1,000 key level, so if you're making a transaction with 1,000 keys involved, a lot of multisigs, a lot of inputs, or batch validation, then we're at the point where we can get a 5x speed up over the single signature time validation. So it's a pretty good speed up. And this has been work that mostly Peter and Andrew Polstra and Jonas Nick, who's here tonight, have been working on trying to get all the performance out of this that we can. So other things going on with the networking consensus. There's BIP 150 and 151 for encrypted and optionally authenticated peer-to-peer. The BIPs are, I think, halfway done, and Jonas Schnelli will be talking about these in more detail next week. But we've been waiting a bit for network refactoring sticker before implementing that in Bitcoin Core. And so that should be work that comes through pretty quickly. There's been work ongoing for private transaction announcement. So right now in the Bitcoin network, there are people who connect to nodes all over the network and try to monitor where transactions are coming through to de-anonymize people. There are countermeasures against this in the Bitcoin protocol, but they're not especially strong. There is a recent paper proposing a technique which is called Dandelion, which makes that much stronger. And the authors of the paper have been working on an implementation. I've been guiding them a bit on it. And either they'll finish their implementation or I'll re-implement it, and we'll get this in, I think, relatively soon, probably in the 0.16 timeframe. It requires a slight extension to the peer-to-peer protocol where basically you can tell a peer, I'd like you to relay this transaction, but only relay it to one other peer. And so the idea is that transactions relay in a line through the network, just one node to one node to one node to one node, and then after basically a random timeout, they hit a spot where they span and go everywhere. So it looks like a dandelion, the transaction curving through the network and then exploding everywhere. And this produces, their paper makes very good arguments for the improvement in privacy this creates. Now obviously if you want privacy, you should be running Bitcoin over Tor, but I think this is a complementary technique to doing that as well. Work that's been started on doing some basically peer interrogation to more rapidly kick off peers that are on different consensus rules. So if I've received an invalid block from one peer, I can go to all my other peers and say, hey, what do you think of this block? Did you have this block? And then, of course, anyone else that says, yes, I have this block, which you consider invalid, well, you can just go ahead and disconnect them because they're obviously on different consensus rules than you. So there's a number of techniques that we've come up with that should be able to make the network a little bit more robust against crazy altcoins running on the same freaking peer-to-peer port. I mean, it is mostly robust against this because we have to also tolerate attackers who aren't going to be, nice. But it is unfortunate when a whole bunch of otherwise honest users start up software that makes them inadvertently attack other nodes. There's been work ongoing for improved block fetching robustness. So right now, the way fetching works, assuming that you're not using the compact blocks high bandwidth opportunistic send, where peers send you blocks without you asking for them, you will only ask for a block from a single peer at a time. So if I say, Ram, give me a block, and then he just falls asleep and doesn't send it, I will wait for a long multi-minute timeout before I try to get the block from someone else. So there's some work ongoing to basically have the software try to fetch blocks from multiple peers at the same time and occasionally waste bandwidth through this. So, yeah.
The dandelion approach, is that going to affect how fast your transaction is going to get into a block? Like if I'm not in a rush, I'll use it, but otherwise...
So the dandelion approach, it can be tuned. And even with relatively modest delays, basically, dandelion, when used in a fully anonymous manner, really should only increase the time it takes for your transaction to get into a block by the time it takes for the transaction to reach the whole network. So only on the order of hundreds of milliseconds. So not a big delay. So I hope that people don't have a reason that they need to turn it off. You could choose to not use it. So if you do.
But it can get into a timeout in a linear part.
Right, and so the original dandelion paper is actually not robust, and if a peer drops the transaction being forwarded and doesn't forward it on any further, your transaction will disappear. So that's obviously a non-starter. And that was my feedback to the authors, and their response was, good, we're working on a robust version of it. And that works via timeout. So basically, every node that has seen the transaction along the stem in the dandelion starts a timer. And the timer is basically timed to be a little bit longer than the propagation time in the network. If they don't see the transaction come in from another peer before them, they go into the burst mode on their own. Yeah.
What?
I know, it's not that surprising.
Yeah. So what if you send it to like a 0.15 node? Like wouldn't that invalidate that approach completely?
No, so with Dandelion, there'll be a service bit assigned for it, so you'll know which peers are able to do it. And when you send a transaction using Dandelion, it will traverse only through a graph of nodes that are capable of it. Yeah. And when this is ready, I'm sure there'll be another talk on this subject here, maybe by the authors of the paper too.
It's also really has great practical applications for command and control systems for bots.
Yes, it could perhaps be used by bots, but so can Bitcoin transactions in general. Another thing that I expect to come in relatively soon is, I guess roast beef is he has a proposal, the GCS-like client, blue maps for blocks, and I expect that we'll implement that in Bitcoin Core as well in the next major version.
There was a talk about that right here.
Yep. A month or so ago, 2 months ago. So all the things I just talked about are things where I've seen code for it, and I think that they're going to happen. Maybe they don't, but most of them will. Going a little further out to where some things I haven't really seen the code for, or I don't believe that the code that exists will be retained. SegWit made it much easier to make enhancements to the script system to replace and update it. And there are several people who are working on script system enhancements, including whole replacement alternative script systems that are radically more powerful. Those are pretty cool, but it's really hard to say when something like that could possibly be adopted. But there's also a lot of minor improvements being proposed, like being able to do Merkle tree lookups inside Bitcoin script that can allow you to build massively more scalable multisig, like Peter presented on a couple months, or a year or so ago, maybe key tree signatures. There is some work done to use proof of work as an additional priority mechanism for connections. It's BIP 154. So right now in Bitcoin, we have many different ways in which a peer can be preferred by doing good work, by being connected for a long time, by having low latency to you. So our whole security model for peer connections basically says we have lots of different ways, and we hope an attacker can't be preferred by all of them. So we'd like to add proof of work as an additional way that someone could get a connections lock priority. There's been some work done for using private information retrieval for being able to privately fetch transaction histories on a Chrome node. So say you have a wallet started on a Chrome node, you don't have the blockchain locally and you need to find out about your transactions. Well, if you just connect to a server to find out about them, you're going to reveal your addresses to it, and that's not very private. There are cryptographic tools that allow you to query databases and look things up in them without revealing anything about your query. They're super inefficient, but Bitcoin transactions are super small. So I think there's a good match here, and we may see in the future wallets using PIR methods to look things up. I've been doing some work on mempool reconciliation. So right now, transactions in the mempool get there just via the flooding mechanism. So if you start a node up clean, it won't have anything in its mempool, and it will only learn about new transactions that show up. This is not ideal because it means that when a new block shows up on the network, you won't be able to fully exploit the speed of compact blocks until you've been running for a day or two and have built up your mempool. We do save the mempool across restarts, but if you've been down for a while, that data is no longer useful. And it's also useful to have the mempool preloaded fast because you can use it for better key estimation. So there are techniques to very efficiently reconcile databases between separate hosts. And there's a Bitcoin talk post I have about using some of these techniques for mempool reconciliation. I think that we might do this in the not so distant future. There's also been work on alternative serialization for transactions that's backwards compatible with all the transactions in history and the existing consensus rules that you could choose to use on your disk or on maybe a peer-by-peer basis to use this compact serialization. And the one that Peter's proposed gets a greater than 25% reduction in the size of transactions. This particular feature is interesting for me outside of working on Bitcoin Core because Blockstream's recently announced satellite system could actually really use a 25% reduction in the amount of bandwidth required to send transactions. So many important improvements in 0.15. I think the most important being that we have is across the board 50% speed up, which is able to get the synchronization time back to where it was in February. And hopefully means that the additional load that's going to be created as people start using SegWit will be less damaging to the system. There are many exciting new things being developed, and I didn't even talk about the more speculative things. I'm sure people can have questions about some of them. One thing I didn't get into, I mentioned a little bit with Newberry, that there are many new contributors joining the project and ramping up, including more paid contributors from several different organizations. And I didn't call people out because I don't know if they want attention, but that's always a good thing. It means that people can contribute on a more consistent basis. And more contributors are always welcome, particularly if people have any interest in working on testing the GUI of the wallet, because those get the least love in the system today. So thanks, and let's move to some open questions. Go ahead and clap. Point of order, the first priority is for questions related to the presentation, but after that, feel free to talk to me about anything. There's been lots of exciting stuff going on in Bitcoin. So,
for the
Mike.
oh yeah, where's the mics?
For the new UTXO storage format, how many bytes is it allocating to the index of the output for it?
So it uses a compact int for that, so it's normally 1 byte in the index. And in fact, it's a little, this format is more efficient than you might guess. I said it's 15% larger, which doesn't sound like as much as you might if you try to figure it out, because LevelDB itself will actually compress entries which contain the same common keys.
What if some of the participants in the Bitcoin network decided not to help activate another soft fork, like, for example, Schnorr signatures?
Oh yeah, so I mentioned that the signature aggregation, which is the Schnorr signature stuff, that's a soft fork, right? It's got to be activated in the network. And so we did have kind of a long slog to get SegWit activated. And I mean, Obviously, people are going to do what's required to make things as appealing as possible. But at the end of the day, right, it's each one of you. It's all the users of the system that decide on what the rules are. And especially for a backwards compatible rule, like a signature aggregation thing that you could optionally use, right, miners are mining to make money. And certainly there are ideological factors involved in it, but running a mining operation is very expensive. And a miner that doesn't want to operate with the rules that the users of the Bitcoin network choose to use is a miner that will soon be bankrupt. Users have the power in Bitcoin. And I wasn't a big fan of BIP 148, though I think it was very successful. But that was specific to its particular timeframes. I think it was way too hastily carried out. I don't anticipate problems with activating something like signature aggregation in the future. But part of the reason I don't anticipate problems is because I know the users will make sure they get activated if they're useful. Thanks. More questions?
Yeah. So if I summarize your...
Sorry.
Mike.
A few rapid fire questions, I guess. So for the new chain state database, is the key basically just the transaction ID and then the output index?
The key is a transaction ID in the output index. Yeah.
Cool. Is it desirable to ditch OpenSSL because it's heavyweight or some other reason?
No, because OpenSSL is really not designed with, so it depends on what parts to ditch it on here, right? Previously, OpenSSL was used all over the code base. It was used for our basic crypto, and OpenSSL isn't really designed and maintained in a way that's suitable for consensus code. So for example, they did in fact change the signature validation in OpenSSL so that it would reject transactions that it previously accepted. And that's an immediate consensus break. So for all of the basic crypto operations, it's easier for us to just have internal implementations and then we can know that they behave in a consensus consistent way. As far as the OpenSSL RNG goes, which is what's remaining, I think that no one who's read that code has to ask why you might want to move off it. It's pretty ugly. But it does have the advantage of being very time tested. And so that's why we're not ripping it out in a super hurry. We're working incrementally so that we can feel very confident what to do.
It's like all of OpenSSL. It's the only thing that's going for us.
Yes, yes. The comment was made that that's like all of OpenSSL is the only thing it has going for it. It's time tested, but that can't be discounted. So.
And then final thing, you mentioned, I think, during fee estimation that in certain cases, miners might try and censor a particular transaction. Have we actually seen that behavior before or no?
So there is one class of that which we've absolutely seen and fully endorsed, which is soft forks. So a newly introduced soft fork to someone who isn't updated to be aware of the new prohibition looks like the miners are sort of gratuitously censoring a transaction. So that's a perfect example of it. We haven't seen other cases of that yet, at least not on a wide scale. There are some pretty scary proposals out there. People have written papers on basically bribing miners to not include certain transactions and things like that. And there are plenty of good arguments for why we shouldn't expect to see that in the future, particularly if mining is decentralized. But we still need to have a system that's robust against it potentially happening. Cool.
Thanks.
So the core of this point 15 was that you created a buffer or a register that was like a moving thing for a certain number of transactions for a certain period of time. So you kept track of the outputs, I assume signatures.
But outputs are the public keys, the things being
Yeah, public keys. So you kept track of those.
Mhm.
And that was the bulk of this.
Of that performance improvement, yeah.
50%.
Yeah, changing how we went about doing that. You have to keep in mind that through the course of the Bitcoin transaction history, the blockchain's pretty big. There have been on the order of 1 billion transaction outputs created and spent through the history. So small changes in the performance of that inner loop operation of finding an output, spending it, deleting it, have big impacts on performance.
So basically, I was thinking if that is possible to use on a non-Bitcoin application of blockchain, say for another application, the same kind of...
Yeah, I think that the same techniques we use for optimization here would be applicable to any system that has similar general properties. But we haven't given a lot of thought to that because our focus working on Bitcoin Core is keeping Bitcoin running. All right, questions? Send the mic back there.
You mentioned at the end of the presentation that GUI and wallet were two of the areas where you guys needed more help. Can you expound on that a little bit more? Especially on the GUI part, because that's my specialization.
Yeah, so there's some selection bias in the Bitcoin projects. The Bitcoin developers are overwhelmingly systems programmers, and we don't even use GUIs generally. And so, and as a result of that, we also attract other systems programmers to the project. And there are some people that work on the GUI in the project, but not that many. So it doesn't get as much attention. It doesn't have, you don't have any big design people, for example, working on it. There's no one that's doing a user experience testing with the wallet. Some of that's okay. We don't intend the Bitcoin Core wallet to be the pretty, blingy, friendly for grandma thing. We do intend it to be a piece of industrial machinery. But there's still a lot of user factors in making a good piece of industrial machinery. And we just don't have a lot of resources going into it, but we'd like more work to be done on it.
Yeah,
Or I can
keep
speak.
talking. Moving on to the talk just for a little bit. How is, I heard, I did read there's, the Blockstream has some people working on Lightning right now.
Yeah.
How's that going?
So the question is, Blockstream has some people working on Lightning. How's that going? So I'm not one of the people that's working on Lightning, so I'm not the best person to ask. But the big news in Lightning is that the specifications for it are coming to completion, and there's been great interoperability testing going on. There are other people in the room that are far more expert on Lightning than I am, including Lalu back there. You might want to grab him when I stop talking and ask him some questions on all things Lightning. And he'll have all the answers, I promise. Yes, he's waving his hand. But I'm pleased to see that it's moving along and people are doing good stuff.
So you mentioned taking out OpenSSL, and but someone is working on secure communication between peers.
Yes.
So I guess that's not going to use SSL.
No chance in that. So I mean, SSL's got a lot of things going for it, particularly that it's widely deployed, but it has an incredibly large attack surface. And for something as narrow as secure communication between Bitcoin peers, we don't need the functionality of SSL, and so we're not going to use it.
If I can comment briefly on that, I think the most important reason why you would want to use OpenSSL is because you need SSL. And for something like this, we certainly have the expertise to build a much more narrow protocol that's much easier to implement without those dependencies.
We also have some interesting things that are different for Bitcoin, because normally our connections are unauthenticated because we're connecting to anonymous peers. And there's some interesting tricks that we can do related to that. Also, we're also very concerned about privacy, so I should be able to have keys that I can use to authenticate to different peers, and I can attempt to use those keys to talk to you, but without revealing who I am when I'm doing that. So basically, tracing resistance, and you can't do that in SSL, and it's something that our design actually has the ability to do. So your use of authentication doesn't make you super identifiable to everything you connect to. So go ahead.
I had a question about, I was wondering when, what do you think would need to happen for 1.0? Like, I know right now, like, we're in the 0.15, like, more like longer term. Is there some kind of special requirement for like when like a 1.0 release? I know it's a little far out.
Yeah, I mean, it's just numbers, in my opinion. The list of things that I'd like to see in Bitcoin Core and in the Bitcoin protocol in general, someone's commenting on improved fungibility, I agree with that. That list is miles long, but I suspect that it will be miles long for the rest of my life. And maybe that shouldn't have anything to do with having a 1.0 version versus not. There are many other software packages that have changed their versioning schemes basically based on marketing. When Chrome started incrementing their major version once a quarter or whatever, then Firefox ended up doing so for purely marketing reasons. There are forks of the Bitcoin software which are doing that right now, calling themselves 1.1 or 1.14.6 to be like one greater than Bitcoin Core in every dimension of the number. I roll my eyes at that. I hope all of you do too, but sometimes those things do contribute to user confusion, and it's not like there's any real benefit to having a low number. So I wouldn't be surprised if the number just got like gratuitously increased to 1,000 or something at some point, because it doesn't matter, right? But in terms of the system being complete, well, I think that we've got a long way to go, because there are many incredible things to do.
There was a recent kind of altcoin fork of the Bitcoin code base that was polite enough to include a reasonable replay protection fix. But people are popularly working on another one that's not going to include that. How can we defend against replays on the Bitcoin Core network?
Well, I think that the most important thing to do is to encourage people to be sensible. But if they won't be sensible and have replay protection, there are many features built in right now that sort of give a little bit of automatic replay protection. So basically, if you look at a computing system like Ethereum, for example, it is incredibly replay vulnerable because it uses this accounts model for handling its transactions. In Bitcoin, because every time you spend, you reference the specific coins you're spending, Bitcoin has automatic replay protection. So, for example, there's no problem of replay between Litecoin and Bitcoin, or between testnet and Bitcoin. Even though there's no special replay protection, they're just taking advantage of the inherent built-in replay protection. Unfortunately, that built-in replay protection doesn't work if you copy the state of the whole system. And there are many ways that it can be restored, but some people don't want to do that. The best way probably to deal with replay is to take advantage of that built-in replay prevention by making your transactions spend outputs that don't exist on the other chain. And so people have circulated around patches in the past that would cause miners to add to their Coinbase outputs zero-value outputs that anyone can spend. And then wallets could then pick up those outputs and spend them. And if you spend an output created by a miner that exists only on the chain you want to spend on, then you're naturally replay protected. I think that if that happens, if this kind of split happens without replay protection, you're going to see people put up tools to help people split their coins. It will still be a mess. And we still see in Ethereum today, even though they have tools to deal with replay, considerable amounts of losses that keep happening due to snafus related to preventing replay there.
There's a altcoin now that copied the Bitcoin state that you can use identical mining equipment on, which appears to be causing this back and forth that at any one moment in time, one or the other of them is more profitable to mine.
Yep.
So only one of them moves forward at any point in time.
It's not quite, but yeah. So system works as designed, in my opinion. Right, so there's the Bcash uses the same work function as Bitcoin. And it does become more profitable to mine right now because they changed their difficulty adjustment algorithm so that when they lose hash rate, they basically go into hyperinflation. And then the rapid blocks coming in once a minute, once per 2 minutes, end up making it more profitable to mine. So what happens is a significant portion, though, far from all of the Bitcoin hash power moves over to the other system, as miners will do because they're trying to make money. Of course, they have to factor in the risk that those coins will become worthless before they can sell them. But so people move over, and Bitcoin slows down. But Bitcoin remains working, stable. Transaction fees go way up. And then that has now twice caused Bitcoin to become more profitable again to mine, just from the transaction fees. So it's self-adapting. In fact, at the moment, Bcash is in its low difficulty period, and it is more profitable to mine Bitcoin right now, even though, because of transaction fees. I look at this as an example of success in the Bitcoin difficulty update algorithm is not attempting to ride over every one of these changes and chase it and going into hyperinflation as a result. And at the moment, it seems to be working okay. just little slow times.
So this situation, Bitcoin's robustness against this would be further improved if we lowered the block size limit to increase transactions.
Well, in fact, one large miner immediately after SegWit was activated seemed to lower their block size limit, probably due to unrelated screw-ups. But yes, indeed. But things, the system seems to be largely self-calibrating, and it's working kind of as expected. Fees are a bit high as a result, but that's all the more incentive for people to start adopting SegWit and taking advantage of the lower fees that will result in.
Is this going to end, or is this oscillation is going to continue?
Well, I'm of the opinion that this oscillation is very damaging to the Bcash side, particularly because it's pushing into hyperinflation. One possible outcome from it is they mine all their future coins, and because their block size is way, way larger than their transaction volume, they allow 8 megabyte blocks, but they're producing 10 kilobyte blocks. I don't know what would pay people to continue to mine it after they've played out the inflation schedule. Moreover, since it'll halve as they do more of this, the amount that they have to jump down to in difficulty will go up, so it should inflate faster and faster. It's interesting, we'll see. There are some miners at Bcash right now that are actually working to try to block the difficulty drops in it because they realize that it's damaging. I'm actually disappointed that the Bcash stuff is having these problems. I think that it's attractive for people to have some alternative. If your idea of the world was that Bitcoin should have no effective block size limit, that's not a world that I can support. It doesn't, I think, make sense based on the science we have today. But if people want it, they should have it. And I was quite happy to be able to say, oh, you want that? Here, go use that thing. But that thing seems to be going off the rails maybe a little faster than I thought. We'll see.
If I give you a chip that is like 1 million times faster than the NVIDIA chip, how much saving would you have on the mining?
1 million times faster than an NVIDIA chip would do nothing for it. No, Bitcoin mining today is done with very highly specialized ASICs that actually a little piece of news. How long until what you were talking about, Ray? So Bitcoin soon will have done 2 to the 88 cumulative SHA-2 operations. No, 87 or 88 because we're doing SHA-2.
Oh, yes.
So, well, we are past it now? All right, so we're over apparently 2 to the 88 SHA-2 operations done for mining. This is a mind-bogglingly large number. A couple, I guess a year, 2 years ago, when we crossed 2 to the 80, I was coming up with some analogies on this stuff, and I figured out that if you started a Core 2 Duo at the beginning of time, it will have just have done 2 to the 80 work back when 2 to the 80 was crossed. And we've now crossed 256 times more cumulative work than that at 2 to the 88. So that's why something like a 1 million times faster NVIDIA chip still wouldn't really hold a candle to the kind of computing power specific to SHA-2 that's applied to Bitcoin mining today.
So 160-bit hashes.
Yeah, I would recommend against 160-bit hashes for any case where a collision is a concern. So we use them still for addresses, but in almost all cases, addresses aren't a collision concern. Though SegWit does change the P2SH equivalent for SegWit to use 256-bit hashes for that reason.
Okay, we have a question there and then a question over there.
There's sort of a few different proposals that are floating around and trying to solve the same thing. Things like weak blocks, thin blocks, invertible bloom filters, and stuff like that. Is there anything in that realm on the horizon? And even if it's not on the horizon, what do you think is the sort of most probable development there?
I'm a fan of, I would basically, there's a class of proposals that I call pre-consensus, and weak blocks is an example of that. It's where participants in the network come to an agreement in advance on what they're going to put in blocks before they find them. And so when the block is found, you don't have to do the work of propagating it. I think those techniques are really neat. I've done some work on them. I think other people are going to do work on them. There are many, many design choices, and we don't necessarily need to have one answer. We can run multiple of these things in parallel. We've made such tremendous strides, though, with efficient block transmission now with the compact block stuff and with Matt's fiber protocol, that it's taken the pressure off a bit. Actually, there was a slide I left out of my graph that We went 5,000 blocks-ish without an orphan a couple weeks ago. So between the new fiber network and recent speed-ups in more recent versions of Core, we've seen the orphan rate drop much lower. And so block propagation is, at the moment, not our biggest concern. And we may see that crop back up again as blocks get fatter with SegWit.
Is a rolling, rolling UTXO hash possibly a precondition for further work there?
No, I think that most of these schemes wouldn't make use of the rolling UTXO hash, although there are some potential interactions for fast syncing nodes on it.
I mean, yeah, just as a way of including a summary of.
Yeah, a lot of these, like the pre-consensus techniques, you can basically have no consensus enforcement in most of the rules, and it's just miners sort of going along with it. They're interesting techniques, and there's a paper 2 years ago now called Bitcoin MG, which itself can be seen as a pre-consensus technique that talks about some interesting things in the space.
Thank you.
Going 5,000 blocks, that would seem to imply that blocks are getting out of the process.
Yeah, so we measure, so Bram's saying that if we're going 5,000 blocks without an orphan, that sort of implies that blocks are going out and getting over the network in under like 200 milliseconds, and that's right, actually more like 100 milliseconds. And particularly Matt's new fiber protocol stuff transmits the whole block pretty reliably in the speed of light distance on fiber to the locations. So it's been pretty good.
Lots of ISPs are 100 milliseconds.
Yeah, so part of the reason that we're able to do this is because this is where Matt's stuff is really helpful, is because he set up a network of nodes which have been carefully placed to connect to each other over low latency paths. And this is very difficult to do unless you actually work with an ISP yourself. So it's taken a bunch of work to do it, but it's helped the network out a bunch.
So we have a question over there, then behind, and one last question. Okay.
Hi, what do you think of proof of stake as a consensus mechanism?
Well, so a couple of things. There have been many proof of stake proposals that are just outright completely broken. And people haven't done a really good job of distinguishing the broken ones. So for example, the proof of stake in NXT is completely broken. You can just stake grind it. The reason people haven't attacked it is because it's not worth attacking. There are other schemes that probably aren't completely broken, but they achieve a very different security property than what Bitcoin achieves. Bitcoin achieves this anonymous, anyone can join, very distributed mechanism of security. And the various proof of stake proposals out there have very different set of trade-offs. For example, the existing users of a system using one of them can exclude a new user from joining and becoming a miner in it by not letting them stake their coins in it. I think that a lot of people working on these schemes have done a pretty poor job explicitly stating what their security assumptions are and showing that they achieve them. There's been also some work in this space where they make unrealistic assumptions. For example, there was a recent paper on proof of stake that claimed to solve all the problems, but its starting assumption is that the users have a synchronous network. And a synchronous network means that all of the users will receive all of the messages all the time in order. And if you have a synchronous network, you do not need a blockchain. You can just have people announce their transactions. And so this was the starting assumption in one of these recent papers on proof of stake. So I think it's interesting that people are exploring this stuff. I think a lot of the work right now is not likely to be too productive. We'll see. I hope that the state of the art and research on it improves a lot, because it's really tiresome to me to read a paper that claims to solve all these problems, and then you get to page 14 and you're like, oh, it assumes a synchronous network. This is into the trash. But this is a new area, and so science takes time to evolve. I hope that answers your question.
So beyond clashing with bad net code in competing forks, what are the highlights of your current threat model for protecting the future of Bitcoin?
So I think the most important highlight is education, right? Because ultimately, Bitcoin's a social and economic system. And if we don't understand it and have a common set of beliefs on it, people are going to manage to muck it up, even if, as it's constructed today, it's very secure. There are some long-term problems related to mining centralization. We've known about them for a long time, and I still am of the belief that they're heavily driven by short-term single-shot events, where basically people entered the mining industry too fast, overbuilt hardware, drove themselves out of business. Maybe after a couple more years of saying that I think that it's a short-term effect, if it doesn't resolve itself, then I'm going to have to get some different answers. But I think the real highlight is education, better understanding, and patience, right? I think that the cryptocurrency space and Bitcoin is so exciting. I'm certainly very excited by the current Bitcoin price. I looked, last time I spoke here, the price is about $580. That's very exciting, but we can't allow our excitement about the adoption to cause us to make bad moves related to the technology. And I want to see Bitcoin expand to the world as fast as it can, but only as fast as it can, not faster. And so we have to curb our enthusiasm with good engineering.
Can I sneak one in real quick?
Hey, so it sounds like you, in November, whenever 2x gets implemented, let's say it does, hypothetically, and it gets more work than Bitcoin. I mean, it sounds like to me you would just consider it altcoin. This is like UASF territory. At what point, you know, is Bitcoin Bitcoin? And can you talk about what y'all would do, especially with the SHA-256 algorithm, if y'all would switch off of that, if SegWit2x gets more work on it?
Sure. Yeah, so I think that the major contributors on Bitcoin Core are pretty consistent and clear on their views on it. We're not interested in the SegWit2x and won't be going along with it. And I don't really see, I think it's unlikely that it'll get more work behind it for the same reason that miners are mining Bcash right now. Miners are going to follow the money. But hypothetically, say it does. This doesn't present me with any great cognitive challenge because I've never been of the opinion that more work matters, right? More work is always secondary to following the rules of Bitcoin. And I suspect that if you did the math, you might find that an altcoin like Ethereum or something has had more joules of energy pumped into its mining, perhaps, than Bitcoin has had. That's completely plausible. You know, I haven't done the math myself. And I don't just suddenly go, oh, Ethereum's Bitcoin now because it's got more joules of energy pumped into its security. Right? That's not plausible. And so every version of Bitcoin from the very first version, all the way back, always has nodes enforce the rules. And that's an essential part to the security and economic model of Bitcoin. Do I think Bitcoin can hard fork? Absolutely. But it's got to be a hard fork that the users as a whole choose to do. And maybe that's really hard to achieve, especially because we can do so many things without hard forks. And I think that's fine, and that's an important part of the security model. Because if you can easily change Bitcoin to take one controversial, probably okay change, then you can change it in lots of other ways as well. And I think that Bitcoin's value proposition is maximized by being able to point at it and go, you can count on it. It's a digital asset that isn't going to change out from under you. So as far as what we would do with proof of work functions in the future, it's unclear. It depends on what adoption of SegWit2x looks like. So I think that in the event that SegWit2x were to get more mining on it, it would probably only be because the users as a whole were adopting it. And I think that if the users as a whole were adopting it, people that are developing Bitcoin today would go and do something else instead. But in the almost impossible situation that SegWit2x has more hash power, but that lots of users are still wanting to continue using the original Bitcoin, then absolutely it would make sense to use a different proof of work function. And I think the test criteria is that changing a proof of work function is a nuclear option, and you don't do it unless you have no other choice. But when you have no other choice, you do it, because duh, do you choose a system that's non-functional or insecure, or do you choose a system that works? You choose a system that works.
So SHA-256 isn't a defining characteristic of Bitcoin?
No, I don't think that it's
okay.
And in fact, actually, we may have to change from SHA-256 for security reasons at some point in the future anyways.
So would you
So-
want to do that as a software, or?
I don't.
So directly to that, Rusty wrote a series of articles about how we can start thinking about if a hard fork is necessary, what does it mean, what does it require, how much time, what kinds of, not saying I'm proposing a hard fork or that a hard fork is necessary, but what kinds of changes might be useful in the short term that aren't a hard fork that will make it easier for us to be able to make a good decision at that point.
Well, I'm generally in favor. So make a good decision is something I don't know that the system could ever really itself facilitate, because deciding over what the system is kind of inherently external to it. I'm generally in favor of a model where we make changes with soft forks, even if they're kind of ugly, and then you try to use hard forks in order to clear up technical debt, but not actually change the economics or properties of the system. And so it should be much easier to get social consensus around those things. I think Rusty's posts have a number of interesting ideas in them, though there is this property that I've observed in Bitcoin, that there's this inverse relationship between the distance you are to the code and how proportional relationship. The distance you have to the code and the operation of the system and how viable you think some of these proposals are. So Rusty, for example, isn't a regular contributor to Bitcoin Core. He's very technical. He's a Lightning developer, but he's also thinks a number of things are plausible that I think are a lot less plausible. And that's a pattern we see in other places as well. So.
Okay, I think that was the last question.
All right,
Thank
thanks.
you very much.